All right. Hello, everybody. Thanks for joining for another session of Blockchain Security 101. Um, we had our first session a few weeks ago where I just gave a general introduction of blockchain security. Then we had a little a Q&A with Chad Fowler and Hasib. And today what I would like to do is really get hands-on and kind of walk you through some of kind of the tools and services that I use on a day-to-day basis. We will look at an attack, and then we'll actually develop a Forta detection bot that will strengthen kind of the Forta detection coverage with that bot. And I think you're seeing my screen. So first, let me kind of introduce you to some of the tools that I'm using on a day-to-day basis. So first, there is the Block Explorer, and the Block Explorer is really just a tool that kind of indexes the blockchain and makes the information available in a UI that is easy to navigate. And there's a lot of information that Blockchain Explorer exposes. So let's take a look at a transaction here. So this is the Etherscan. So this is for Ethereum mainnet. I pull up a transaction here, and you see a whole bunch of information, kind of the block it was mined, how long ago it was mined, what this transaction actually did. Was it a transfer event, or did it interact with the contract? So what you see here is that this 598 address interacted with this contract 0x51, which is the chain link token. As you see here, Block Explorer really augments the information to make it easy for you to understand. So it's not just giving you the address, it also gives you kind of information what that represents. And so this particular transaction, and so this account interacted with this contract, and if you click on more, you're actually able to see what function got invoked on the smart contract. And so in this particular instance, the approve function was invoked, granting a particular address access to the link token held by the 598 address. And how much was the granted? You see here FFFFF, essentially an infinite amount. So what this transaction did is it provided this address essentially with full access to manage the link token on behalf of this particular user. Etherscan I use it pretty much every day. There's also an API available that allows you to get like aggregate information. So if you're, for instance, interested to get, let's say, the ERC20 token account balance for a particular token contract address, there's an API. Or if you're interested, hey, give me all the transactions for a particular account. So there's an API for that. There's also Tenderly. You've got to be careful with your URL because it's Tenderly CO, which is also a block explorer. So let's take the transaction that we had here and just kind of put that into Tenderly. It gives you very similar information as Etherscan. The big difference that with Tenderly is that you're able to simulate transactions. So there's a debugger that you're able to hook up that really allows you kind of do a step-by-step debugging session, which is not possible on Etherscan. So those are block explorers. Now there's also a set of libraries that you're able to use to interact with the blockchain. So I'm not very familiar with JavaScript. I'm primarily focusing on Python, and so I am using Web3.py, and let's just kind of pull that up here. Oops. And what this API allows you to do is really interact with the blockchain in a programmatic fashion. You're able to query information about the blockchain. You're able to submit transactions to the blockchain. Usually as an end user, you do that through kind of MetaMask that kind of handles that for you. But you can also do that programmatically with this library, and that there's others for JavaScript. So for instance, if you're interested in getting the code of a smart contract, there's a function, get code. You provide the address, and then you get the code essentially. So similarly, what we did on the Block Explorer in terms of getting information about the transaction, that's what you see on the screen right now using the Web3 library, where essentially we first connect to an RPC endpoint. We make sure that the connection succeeds, and then we get the transaction. And this is the same transaction that I pulled up on Block Explorer. And you see essentially the identical information here. And so if you need to analyze kind of transactions in a programmatic way, this is the way I personally do it. Now, this library is great, but it also has some limitations. So let me give you a particular example. So let's assume I want to get all the Chainlink approval transactions. What I would need to do with this particular library is really iterate through all the blocks, all the transactions, and check every single one to assess, hey, is it a Chainlink approval? That is, computationally very expensive. It's really not feasible to do with this particular library. And so there's a couple of services that I use that essentially index the blockchain and make it available in a queryable form. This is Luabase. And so let me see here. So it's basically a SQL-based language. So it allows you to basically just kind of pull up transactions in aggregate. And then there is fields exposed here that allow you to query for particular conditions. Again, very difficult to do with the Web3 library. The other service that and the nice thing about Luabase is that it is free. Now, the other tool that I use is Dune. And Dune does some very similar to Luabase. It essentially indexes transactions, but then it also kind of categorizes them in tables that are queryable. And it parses logs, extracts information, puts that into fields. And so it really, I think really anything is queryable through Dune here. And Dune then also allows you to create dashboards to kind of track what you're interested in over time. So for the transactions, the approval transaction, so instance, what you're able to do here is select star from, and so they're interested in ERC 20. sometimes a little challenging to find, but you will see it here. So we have here ERC 20 approvals, where, whoops, event transaction hash equals, and thing to keep in mind, sometimes the format is a little bit different. So here it's a backslash x versus a 0x. Oops. Event transaction hash. Oops. Yeah, it's not me. Huh. And so then basically you get the same kind of data that we've seen in the block explorer. But now think about how powerful this is, because if you're like, again, interested in, hey, give me all the event approvals where maybe the value is a certain value, you're able to query that and get that back essentially within a few seconds. So those are some of the tools that I use on a daily basis. So now, next, what I would like to do is go through an attack with you. And so this is an attack that Forta detected early last week. And this was the fake token exploit. So we can pull up the exploiter address and see what we see on the blockchain. So there's not a lot of transactions here. One thing to keep in mind, there is 2 tabs here, transactions and internal transactions. Transactions are essentially the transactions where the address that you're looking up is either involved in the from or the to. But the transaction could also, the address could also be involved in an internal transaction. Let's say a contract gets invoked, and then that contract will send you some tokens. And that will show up on the internal transaction tab. And so what you see here, so 9 days, 14 hours ago, so at 11:24:59, let's go back here, look at the first transaction, timestamp 11:28, so this is after. So let's look at the internal transaction. So this was really the first transaction where that address ever appeared. And basically what is happening, this particular address got funded by Tornado Cash, which is a privacy protocol. Then the next transaction you see here is the account creates a contract, but it seems to fail. And the reason is because they didn't supply too much gas, sufficient amount of gas. Then next, you see a repeated contract creation. This time it succeeds. So let's click on that one real quick. So here you get information about, oh, the contract was created. It gives you the contract address. And so then we could like jump to the contract. Let's take a look at that real quick. So here we have the contract. Transactions, we can go to the contract tab, and you see essentially all the bytecode of the contract, which is, hard to understand. Usually what happens when protocols submit their smart contract, they also submit the source code along, and then Etherscan essentially verifies that the source code actually compiles into the bytecode that is associated with the smart contract, and would show that with a little verified tab. This didn't happen here. I think that's already a suspicious signal, but I'm not saying it's malicious. Often smart contracts are deployed that way. Now, what else can we kind of glean from here? We can switch to the bytecode. Oops, nope, sorry, not the bytecode, the opcodes. Let's switch to the opcodes. And so again, this is very cryptic, but you can just kind of scroll through. And as you scroll through, eventually you will find things that look like addresses. And so here, for instance, we have an address. And so let's go to Etherscan and look up that particular address and see what that is. Oh, that is a contract as well. And it happens to be the Tether USD contract, so USDT. So just by looking at the opcodes, you can extract addresses that give you some indication on what that contract may do. From what I just looked at, I know that it will likely interact with USDT tokens or use USDT tokens. Let's go back to the transactions. So contract is created. We knew that the address was 0xF02 from what we looked at earlier. And now here is a transaction where the account actually invokes a function on the smart contract. Let's look at what that function looks like. So there is essentially the function that is getting invoked, which is essentially a hash of the function signature. Now, one thing that, and it's 4 bytes. And one thing to note here is if that function would have parameters, you would see them as well, encoded here in this input data field. So what that implies is the function was invoked with no parameters, which is also a little bit unusual. You see that there are a whole bunch of tokens being transferred. I mean, there are a lot of transactions here. There's also a swap on Uniswap. And that's a lot of information. Internal transactions, also, if you look through that, a lot of things happening here. If you look at the logs, you can see essentially the events that are getting emitted as this particular function is getting executed. That also includes the events of any smart contract that got invoked. So again, a ton of information here. But what I usually look at is the state tab. And again, Etherscan does a great job with this, because basically what it shows you is the state changes for the various addresses before the transaction and after the transaction. And so if you scroll down here, you can look at the state differences. That's probably what you want to pay attention to. You see that this particular contract or this particular address, the FETH token supply reduced from 1200 to 900, so about 300 ETH moved out, and the address that invoked the smart contract, well, somehow gained 300 ETH or 290 ETH. Probably not equivalent because they're essentially trading it. So that kind of implies that, well, FETH may have been attacked. And the way I look at analyzing attacks at this level, I'm not necessarily looking for understanding in detail on how the attacker accomplished what they did. I'm trying to look at the evidence presented to me and eventually make a judgment call on this is likely to be an attack. And this is yet another indicator that this is likely to be an attack. And so if you look at the FETH token, so this is the FEG wrap token, and so the FEG protocol was likely involved in this particular attack. And then if you look at the remainder of the transactions, well, you see that essentially now the attacker has 300 ETH, and they immediately send it to Tornado Cash. And so if you look at this attack holistically, there is essentially 4 things that happen. The attacker got funded by Tornado Cash. Then they prepared an attack because they created a smart contract. Then they invoked the smart contract to steal tokens, 300 ETH, it's about $500,000 roughly. And then they quickly proceeded to essentially money launder. And those are kind of the 4 stages that I'm looking at to assess, hey, is this an attack? And so let's look at how this particular attack looked like on Forta. So we go to forta.org, we launch the app, we go to the Forta Explorer, and then we will look up this particular address. And usually first thing I do is really go to the end of the transaction history for that particular account. And what you will see here is essentially the Forta alerts that correspond to the transactions that we just looked at. And what that then allows you to do is kind of assess, well, okay, I looked at the Etherscan transactions. There's a whole bunch of kind of indicators that I had that points to suspicious activity or to an attack. And what I'm doing here now is let's look at Forta and see how do those 2 relate to each other. So we see that there is a Tornado Cash withdrawal. We see suspicious contract creation by a Tornado Cash funded account. If we click into that particular alert, what Forta attempts to do is not just raise an alert, but also give context around information that may be useful for the subscriber of the alert. And so in this particular instance, you see here there is a bunch of addresses that were involved. And what this particular alert actually does, it extracts the addresses from the smart contract code, as well as the memory storage location, and makes them available here. And so remember that we looked at one of the tokens, I think it was this one. Let's see whether I recall correctly. No, that's the Uniswap one. I think it was this one. Yeah. So here we have the FEG wrapped ETH. And so Forta makes that available essentially in the alert itself. Let's go back to the end. Okay, and then so just making sure I'm at the end. So there's a whole bunch of alerts related to the contract creation, and there may be some duplication in alerts. Forta obviously is a community-driven project, and people are developers, security researchers are adding their bots, and so sometimes there's some duplication there. If we continue to look at what's happening, there's high gas usage. Let's look again at the transactions here of the exploiter. Just a second, let me pull that up again. So here's the exploit transaction, and we see, oh, there's a flash bot, which is essentially a way to bypass the mempool, and also high gas. So we have that visible here. There's some approval events, reentrancy detected, native token transfer, so a lot of value here, and then Tornado Cash funded account interacts with the contract, and then possible money laundering. And then what we have just deployed recently is an alert that kind of combines a whole bunch of alerts together to really create a critical event. And that's what you see here. Alert combiner identified in EOA with past alerts mapping to an attack. And so for this particular attack, I think we have great coverage in terms of the alerts that are emitted along essentially all the stages of the attack, with essentially an opportunity for a protocol to take action before funds are getting drained. Now, if you look at this particular attack, this would have to be automated because the transactions happen very quickly in succession, right? So we have, at 11:29, and then a minute and a half later is essentially the attack transaction. So not a lot of time to respond, obviously not manually, but in an automated way, you could. There are 9 blocks in between those 2 transactions. So that is kind of the attack. So next, what I'd like to do, and just give me a second. Next, what I would like to do is make Forta protection and detection coverage even stronger. And let's look again at the attack transaction. There's a lot of transactions here that are happening. One thing when I looked at this particular attack yesterday that was kind of interesting is this fact of, there is a function being invoked without any parameters. And what I was wondering as well, how common is that? I can certainly think of some functions like the pause and unpause function that does not take any parameters. But usually when a smart contract is invoked, I usually see parameters. And so is that a viable detection bot? Now, one thing that you may be thinking of now is, well, invoking a smart contract without a parameter, that is not malicious behavior. So we shouldn't really author a detection bot on that. The way I think about this is more around there's different types of alerts. There's alerts that Forta emits that are merely informational, that say, hey, something is happening. Let's say kind of like a pause, unpause, right? You could have an alert that just says, hey, this contract was paused and unpaused. That's just an event, and Forta exposes those. Then there is, on the other side of the spectrum, alerts where, yes, this is an attack. As a detection bot, I'm super confident about it. I raise an alert that is critical. But then there is essentially alerts that are in between, that are not an event and not kind of malicious, but really more of another indicator. And while in isolation, these sort of suspicious signals are noisy, if you think about building a layer on top of all the alerts that Forta emits through ML, through anomaly detection, then you can combine these suspicious signals together to separate out the signal and the noise and really emit a high confident, highly precise alert. And the alert combiner that I showed you earlier is an example of that. It is very simple today. It basically just says, hey, if there's an alert in these 4 stages of funding, preparation, exploitation, and money laundering, then I raise a critical alert. But it feeds off detection bots that emit suspicious signals. So that's just kind of my take in terms of kind of, is this worth a detection bot? I feel like absolutely. So let's create that. So first of all, let's go to kind of the Forta documentation. So we have our getting started, developer resources, gives you links to the SDK, and then also kind of how to build a detection bot. So that gives you some introductory videos. And then if you go to detection bot developers getting started, it gives you step-by-step instructions on how to build your bot. And so that's what we're going to do now in the next 25 minutes. So we'll see. Hopefully, we'll be able to finish on time. So I am using so first of all, let me go here. So first we create a folder, tutorial 3. And then if we go back to our documentation, I mean, that's basically what it tells you to do. This, of course, assumes that you have already all the prerequisite filled, Node.js installed, Python, Docker, etc. Again, I'm somebody who develops bots in Python. You may be more comfortable with another language, JavaScript, TypeScript, and so you can initialize this any way you would like. And what this essentially now does, it pulls all the packages down and gives you a first instance of a bot. So let's look at how that looks like. So we go to tutorial 3. Let's open that particular folder. All right. And so you see there's a whole bunch of files that are being downloaded, and an initial agent. And so the initial agent here is an agent that will alert on transfer events of Tether tokens. And I think there is a threshold somewhere right here that basically alerts if more than 10,000 tethers were transferred. So this is really just kind of a skeleton that you're able to work off. Now, there's also unit tests that you're able to run. And so let's just kind of do that to make sure everything is set up correctly. And so we have the unit tests. So first thing that I tend to do is, first of all, work on the documentation. That personally brings me a lot of clarity in terms of what I want to do. And so in this particular bot, I want to essentially monitor contract invocations. And in the description, this will alert on unusual contract invocations. Supported chains. I don't see a reason why this would not work on really all EVM related chains. Then here we need to describe the finding. So essentially the alert that would get emitted. And I want to be quite specific here. So contract invocation dot parameters. And this fires when a transaction invokes a contract without any parameters. At this point in time, I feel like this should be a low severity and maybe and then also type info. And then we probably want to expose the actual function hash in the metadata. And then we also want to make sure that we have kind of like a test transaction. And we just looked at an attack, which I think is an excellent test transaction. So we'll take that particular transaction. And what you're also able to do is run this particular transaction. Let's see here. Oops. Sorry. I hope you're still able to see my screen. It's just that window in between. So you can run essentially locally your bot against that particular transaction. All that I'm basically still running the starter kit, or not the starter kit, the kind of the example bot, the tether transfer bot here, because we haven't changed any code yet against that transaction. So it doesn't find anything as expected. But later on, once we change our code, we would expect that a finding gets emitted. Also, what you can do is run it against the blockchain data that is coming in a live fashion. And I certainly recommend to do that as well, to kind of assess the noise level of your bot. So we stop that. Other things that we want to adjust here right from the start is the name. So in location. So agent. So there's a bot. Change this in a few locations. Also this JSON file, and right here as well. And then the other thing that I usually do is turn on logging for the Docker container. That's more important when you deploy. So now we got the README, the JSON adjusted, and the Docker file. Next up, we may want to, and maybe I should have done this before, is look at kind of how noisy will that bot be. And we can develop the bot, we can deploy the bot, and wait for transactions to come in. That may be a little slow, and maybe not the kind of the most efficient way. I'm reading from my document here, so don't be impressed that I'm able to kind of remember all of this. Basically, what I'm doing here is kind of implement the bot logic on Dune and test this out. Oops, it is. And so basically, block number. And so basically what I'm doing is saying, hey, if there's a transaction where the length of the data is 4 bytes, meaning just the function gets invoked without any parameters, and then I'm kind of constraining it a little bit in the the block number range. So essentially Dune is able to return quickly. Oops. Oh, they're actually to return. So you see some functions here. Whoops. So you see some transactions here where it hit. And so that allows you now to, and I'm sorry, my screen is a little small here, but that allows you to kind of get a sense of, well, are there other things that may allow me to carve the data a little bit better in order to reduce noise level. And so one thing that we can look at is the, whoops, where is it? The data field. So here you basically see all functions that get invoked without any parameters. And what you'll notice is starting to see, oh, there are some repetitions. And these may be some common functions like pause and unpause. The other thing that I noticed when we looked at the transaction, so let's look at it again, is that this account has a very low nonce. So nonce is a sequential number that essentially increments with every transaction, starts at 1, right? Or 0, I'm not 100% sure. So basically what this indicates is this particular address in the first 2 or 3 transactions invoked a contract without a parameter. And so how common is that? And so you could start saying, and nonce is less than, let's say, 3. That, hopefully that returns very quickly. Of course, there is a little bit of a trade-off, right? Like you're making it more specific. So here, as you see here now, there is, whoops. There should be a little less, so there may be some bug here that I don't spot right now. But my point is there's a trade-off that you're making now in terms of how precise you want to make your bot and remove essentially false positives. But then how wide of a net are you casting? Again, a bot does not necessarily need to be highly precise to be valuable. You have to think about that the alerts are then being used in a larger context, like through the alert combiner. So then kind of let's go briefly into the coding here. So what you see here, of course, is all the things that were essentially part of the sample bot. So we essentially remove all of that. So we just kind of have an empty skeleton, and we do that for the test as well. Test contract invocation. Let's say test returns empty if data length invocation with parameters remove most of this here. Okay, so now what we need to do is create a mock event. This is really just a testing stub. And mock transaction event, and we want to set action data. to some value. So let's set that to 0x. So basically here we're saying invoke with parameters. So FFA, that would be the function. And then we basically just have some parameters. Oops. And we set the to address to some value. We set the from address to some value. And that is essentially our test now. So basically we're saying if the data field, so think again of essentially what you're seeing here, is longer really than 4 bytes, which implies there is a parameter being passed, then we don't want to have any finding. And then let's just kind of copy paste and do the opposite. Turns finding if invoke without parameter. And so that essentially would snip off all of this. And then we want to have the finding here. And so that's our test. And this should compile. So let's see what our test says. Fail. Okay. Because it still, I didn't save. So here, let's do it. Again. There's still some imports here from the previous one that no longer exist. Here we got our assertion error. All right. So now basically what we want to do is have now our test that has kind of the 2 conditions. And now we really need to implement the logic of the bot. And so what we want to do is extract the 2 from. And you may notice here some code complete. And this is Codex, which is essentially an AI that assists programming, which I personally find very helpful. So we essentially extract kind of the 3 fields that we need for our logic. And we essentially check if the data length is equal to 10. And the reason why we use 10, so I'm just going to add a comment here. So if you think about string representation of the data field, it is actually size 10 of a 4-byte field. And then we essentially append a finding. And we give it name. Make sure we got all of this right. Description. Let's make that a little bit specific than my AI would like. So we here really want to say from invoked to without parameters. So it got that right. And then we want to do an alert ID. And that is what we had in our README. So let's copy that. Whoops. to set it to documentation. We have the type, set that to info for our documentation. And then metadata, we said we're going to set the function exposed in the function hash parameter. Okay. So we say data equals to data. Let's see what our test does. And boom, it passes. So now you have created the bot. Again, what you can start doing is npm start. Well, let's actually run it against our transaction first that we identified that was associated with the attack. And as you see, now there is a finding that gets emitted. Contract invocation, it has the address of the fake token exploiter, as well as the contract address, appropriate severity and type, and we also have the data in the metadata field. Now, the next step that you may want to do is run npm start. And basically now what that does, it will run your bot against the live blockchain. As kind of transaction come in, it will put your bot through the logic. And as you see here, it triggers a few times per block. So that means this would be quite a noisy bot. So that may be fine again, or it may be something that you may want to revise. Maybe you want to include, again, kind of the nonce heuristic and kind of combine two heuristics together to kind of, again, better separate the signal from the noise. And then as the last step, you would npm publish, and your bot would then essentially deploy onto the Forta network. It will get assigned to the scan nodes. We have over 1,000 scan nodes on the Forta network right now. There's some redundancy. Your bot will run on multiple scan nodes at the same time. And then shortly thereafter, you should start seeing alerts coming in. And here is the bot, which I deployed yesterday. So let's take a look at this particular bot. And you can see that it's starting to emit alerts. Now, when I did it yesterday, I also incorporated the nonce logic that I talked about. And so it fires still several times. But again, the way I look at it, it's an additional signal that can be utilized in a holistic context to understand whether an attack has happened. So that's a lot, I know. If you're interested to develop a bot, I very much encourage you to take a look at the quick start guide. It is really simple. You can have a bot up and running, a valuable bot up and running in a couple of hours. I encourage you to take a look at, let's see here whether I can find it. Our site has changed a little bit. Past hacks. So these are past hacks that we analyze where Forta generated alerts. So there's usually a Twitter feed or a write-up that gives you also the indicators. And that is a great starting point to kind of look at attacks on the Block Explorer, really understand the Forta coverage, and that will also give you ideas on what bots you may want to develop. I encourage you to join our Discord. There is a, you find the link down here on the Forta.org. There is a channel there, Bot Ideas. If you don't know kind of where to get started, or hey, you did an analysis and you have some ideas, share them there. It's a community-driven project, and we're all in it together to secure Web3, and that's really what it's all about. So I hope you found this session useful, and thanks so much for your time.